Hello, this is simply about networking protocols, and today I'll tell you about DHCP and DHCP relay. Standards that describe in DHCP is RFC 2131, DHCP relay is 1542, and DHCP options, not all but most, 3046. In this video, I'll tell you about DHCP, DHCP operations, and how DHCP relay influences DHCP operations. From your head, you most likely imagine topology related to DHCP as multiple clients connected to the DHCP server and communicating to each other. Well, that is correct. Taking into consideration that communication between client and server doesn't depend on communication between other clients and servers, this topology can be simplified for verification needs, and you can have one client, one server, because they have all the same operations. If you don't need to verify scalability or big numbers. Okay. You also should take into consideration that DHCP is dialog protocol. It means that there is an identifier of the client that needs to be used both in communication from client to server and from server to client. In other words, client, when generating DHCP packet, fills in this identifier and sends to server, and server needs to reply with the same identifier in the packet. Otherwise, client will consider packet not destined to itself and will drop it, and there will be issues in the verification. So either use standard hardware or software emulators, or take this into consideration if you're writing your own scripts. Now, to cover as much as possible in the simple manner from DHCP operations, let's take a topology, single LAN, multiple DHCP servers, and work with it. DHCP operations, in general, this is sending packets from client to server and from server to client. And all that starts with DHCP discover. DHCP discover is the literal question from the client to the network, to all devices in the network: are you DHCP server? Well, also take into consideration that DHCP server can provide huge amount of the configuration to the client. And in many cases, client doesn't need all of it. So client in the discovery can ask for specific configurations that client is looking from the server. And this is done by specifying specific options in the options field of the DHCP packet. So accept multiple mandatory options that must be in the packet, but again, depends on the vendor. Carefully read your vendor specification. But in general, there are mandatory options that needs to be there, and additional option that client can put here saying, give me this configuration or this information. Okay. Let's imagine that our client is looking only for IP address. This is some new device appears in the LAN, wants to receive IP address. And it starts with DHCP discover saying, are you DHCP server? Can you please give me IP address? Every device receives this, not DHCP servers drops packets. DHCP servers reviewing their configurational databases, picking free IP addresses. By the way, DHCP server can be configured even to ping this IP address to ensure that it is free and not taken by any other device for any reason. This is configurable, and DHCP server configuration, this is huge thing and should be discussed separately. So DHCP server picks and ensures that some IP address is free and sends DHCP offer to a client. Important, IP addresses in their databases are not blocked, not allocated yet. Everything is smoothly. DHCP client can select first offer. DHCP client can be configured to take all offers and somehow select the best one. Depends on the configuration, but DHCP client somehow selects the best offer for it and sends DHCP request. Only here DHCP request appears. DHCP request saying give me specific IP address already from those that server sent previously. In the packet, it identifies IP that wants to receive, server that wants to communicate. So server that is not aimed to be to continue this communication just ignore the packet and stops its activity. Server that aim to continue communication receives the request. If request somehow differs from offer that this server sent to client, in any case, if there are multiple options that client requests, if number of options change, if some option has changed, if DHCP client identifies specific server but specifies different IP address from the offer, for any difference between offer and request cannot be executed, and DHCP server generates NACK packet. NACK, here is N, okay? It's saying that request cannot be executed, sorry, try another time. Client receives this, understand that something goes wrong, and depending on the configuration, performs following actions. If request meets offer, server, in our case, allocates IP address, only now allocates IP address and sends ACK packet. You see here is no N, ACK packet saying that, okay, this request acknowledged, this IP address can be used, client receives ACK and start using this IP address. Also, there is a procedure of graceful release of the configuration. So when client goes down and don't want server to wait least time and wants to LAN operates smoothly, it can send release packet saying that some configuration allocated for this client can be released. DHCP server, by receiving this packet, releases allocated configuration and can use it again for another devices. For example, how DHCP relay influences these operations? Well, it is ambiguous to have DHCP server for every subnet on every network because it's huge and pretty expensive. And one DHCP server usually serves multiple LANs. Then DHCP relay put in between, and feature or operations of the DHCP relay is to transmit information between clients and server. Important, not transmit packets, but information. DHCP relay doesn't forward or float DHCP packet. It receives it, processes, and generates new one in necessary destination, to necessary destination. So how it works? DHCP client sends DHCP discover in the LAN. Every device in the LAN receives DHCP discover, including DHCP relay. Relay receives this packet, applies it, and sends to the server from DHCP relay, but in name of its client. How this implemented? It's implemented by additional option in the DHCP packet, option 82. This option 82 identifies DHCP relay. Also, GI other field in the DHCP packet also identifies address of the relay that generated this packet. So DHCP relay sends discover to the server, server receives it and operates in normal way. It replies with an offer. Since there was option 82, server keeps this option 82, notifying relay that relay needs to process this packet, because identifier in the packet is identifier of the client all the time. Okay, offer is generated, DHCP relay receives it, processes and sends offer to the client from the name of the server by removing option 82 and GI addr. And client receives like offer directly from the server. This is how it works. This is how it is simple. Thank you. Have a great day.